Join me as I dive into the world of AI and challenge myself to explain alpha beta pruning in just a few minutes. Alpha beta pruning is a game changer in artificial intelligence, especially when it comes to decision-making in games. It's a key component of the minimax algorithm, which helps computers make smart decisions by evaluating all possible moves and their outcomes. This is crucial in games like chess, where the number of possible moves is staggering. Optimizing search algorithms is a big deal in AI, particularly in complex games where evaluating every possible move is computationally expensive. Think about it, in a game like chess, there are over 10 to the power of 46 possible board configurations. Evaluating each one of those would take an eternity, even with the fastest computers. So, we need to find ways to prune the search tree, focusing on the most promising moves and ignoring the rest. This is where alpha beta pruning comes in. The problem with simple search algorithms is that they can get overwhelmed by the sheer number of possibilities. It's like trying to find a needle in a haystack, except the haystack is on fire and the needle is hiding behind a million other needles. Alpha beta pruning helps solve this problem by keeping track of the best possible score for each player, allowing us to cut off branches of the search tree that are guaranteed to have a worse score. Another challenge is that search algorithms can be really slow. In games like Go, there are so many possible moves that a computer would need to evaluate billions of possibilities per second to play at a decent level. Alpha beta pruning helps speed things up by eliminating unnecessary branches of the search tree, making it possible to play complex games at a high level. Alpha beta pruning works by maintaining two values, alpha and beta, which represent the best possible score for each player. Alpha is the best score that the maximizing player can guarantee, while beta is the best score that the minimizing player can guarantee. As we explore the search tree, we update these values and prune branches that are guaranteed to have a worse score. The terms alpha and beta might sound complicated, but they're actually pretty simple. Think of alpha as the best possible score for the player who's trying to maximize their score, and beta as the best possible score for the player who's trying to minimize their score. By keeping track of these values, we can eliminate branches of the search tree that are guaranteed to have a worse score. One famous example of alpha beta pruning in action is the chess program Deep Blue, which beat Garry Kasparov in 1997. Deep Blue used alpha beta pruning to evaluate millions of possible moves per second, allowing it to play at a superhuman level. This was a major achievement, and it showed that alpha beta pruning could be used to create really powerful game-playing AI. The impact of alpha beta pruning goes beyond just chess, though. It's used in all sorts of games and applications, from video games to financial modeling. Anywhere that you need to make smart decisions in a complex environment, alpha beta pruning can help. In conclusion, alpha beta pruning is a powerful technique that helps computers make smart decisions in complex games. By pruning the search tree and focusing on the most promising moves, we can create AI systems that play at a superhuman level. So, what do you think about alpha beta pruning? Have you got any favorite examples or applications? Let me know in the comments. If you're interested in learning more about AI, be sure to check out my next video on advanced AI techniques.